Hey, let's take a look at how we do some angle constructions. We've recently worked through segments. We'll just take a look at a couple things about how to copy angles, bisect angles, and add, well, and subtract. So here we go. So I wrote something up just so I had something kind of ready to go. So I've got this angle right here that I'm calling angle B. And I want to copy that. Now, keep in mind that an angle is formed by the intersection of two rays. And since all rays pretty much are the same thing, we just always start with a ray. So what I need to do now is try to build this angle on top of this ray. So the first step is we take our compass and we open it up to a value that feels comfortable to us. Now, when you open up a really, really big, it's hard. Usually very, very small is difficult. I just try to make an opening that feels somewhat comfortable. And I come up to my angle and I draw an arc. And then I make exactly the same arc on the ray that I'm going to build on. So I make exactly the same arc on both. Now, this actually models something that's a little bit interesting is sometimes you end up going, oh man, my ray, I would have liked my ray to be a tiny bit longer. And so you can always extend it a little bit if you need to, since rays go forever. So I copied the same arc on these things. If your arc is bigger or smaller, it's not going to be a problem. Now I'm going to go ahead and measure the gap between these two coordinates that I just created, right? So I'm basically finding out how wide my angle is upon this arc. And if I can copy this value from here to here, so again, I measure this value between the two along the arc that I did, pull it down here, and as soon as I make an arch off of that or an arc, all I need to do is connect the dots, and I now have a nice, simple angle that would be exactly the same as angle 1 or angle B. Now notice this time I said angle B because B is my vertex. I'm also going to talk a little bit about vocabulary. So over here, I named this angle B based on the vertex angle. Over here, I use the alternate definition. The way we define angles was DEF. Notice that E, the value in the middle, has to be my vertex. So just like the previous problem, I'm going to start with a ray. I take this compass and I open it up to a value that just feels somewhat comfortable that will fit on my paper well. I draw an arc across the angle and I just make sure that it is long enough to hit both of the rays. And I make sure that I do the same one here. And we do have to eyeball about how big this arc is because I'd like to make them the same. So I've got two matching arcs, one from this point E, one from this end point right here that I'm building on. Then I measure how large the gap is on my angle. In other words, I'm finding out how large my angle is. I copy down to here. Again, measure the gap, slide down and copy it. And then all I have to do is connect the dots, and I have copied my angle. And if we do have something, sometimes it's nice you can actually validate. So I'm going to take out here a compass, a protractor, excuse me. I'm going to see how big my angle is. So I take the little dot right here and I line it up on my vertex and I line up this line right here along my ray. And I look for what number that it actually lines up with. Have that upside down. Okay, so here we are. So it looks to me like either this angle is going to be, what is it, about 83 degrees, or maybe it's 103, or I think that's right, 103, or maybe it's 77. But I think I can tell that this angle is acute, so I know that that's 77. Now the reality is, we know what it is because if you follow where the ray points to 0, that's the side you look at. So wherever your introductory ray is, you follow that 0, and that was on the inside on this one. And this one, therefore, should also be 77. And if you follow this along, it actually was successful. I did get a 77-degree angle. Understand that compass and straight edge constructions are difficult for people, so don't be too picky on yourself if you did the process right, but it doesn't look perfect, okay? This is a process. It does take a little bit of time to learn how to do that. Now, I think this next one is a little bit harder, and I've asked right here to go ahead and construct a brand new angle that I'm going to call HIJ, which is going to make I my vertex, but I want it to be as big as angle 1 and angle 2 added together. So I've got these two angles right here, and I want to make this brand new one. Now, keep in mind, my new one is going to be this big and this big together. So it's going to be, oops, sorry about that. I just knocked my camera over. It's going to be a very, very large angle. So that means I'm going to need a pretty good size arc to make this work. So here we go. We always start our story with a nice ray. Then we pick a random arc, and it's an arc of our choice. Now, I could pick the same arc that I had before, or I could pick a new arc. I'm going to pick a fairly small one because I think I did one that was a little bit too big before. So I'm going to make a really substantial arc because I don't know how big this angle is going to be, but it's probably going to be obtuse, I would guess, from what I saw. And I'm going to make these up here. Now, keep in mind, I got to pay attention because now I have an extra set of arcs. Oh, I got lucky and I picked the same one on this one. So I made the same arc from all three. Okay, so I made an arc on my original one that I'm going to copy to, and I made an arc on B, and I made the same arc on E. I happened to get lucky and hit the same place that I had before. Now I need to measure my gap and copy that gap. Now keep in mind that gap is going to be sitting right here. So I have now copied angle 1. But I want to also then copy angle 2. So going up here to angle 2, I'm going to measure how large angle 2 is. And remember, my goal is to add it to angle 1. And so since angle 1 ended right here, I'm going to add it to angle 2 to angle 1. So if I were to draw this part, I had angle 1. This part is angle 2. So if I connect the dots, I have my angle HIJ. You can see angle 1 right here, angle 2 right here. And so this is going to be angle HIJ. And I was planning on doing a subtraction problem, but the only issue there is if you subtract, then instead of going further forward, you just then come backwards to make the angle smaller. So to keep this video shorter, I'm not going to go ahead and do that. But when you add, you just keep making the angle bigger. To subtract, just like in the segments, just turn around and go the other direction. Now, the last part of this video is how to bisect. And if you want to bisect an angle, we always start with a random thing because we don't have anything really to measure, a random gap. We make an arc that makes sure to cover the entire angle that hits on both rays. This next step is kind of, it's important. You can do the same arc. And in fact, a lot of books tell you to keep that same arc. It doesn't have to be. You can actually make it a little bit smaller. So I'm choosing to make mine a little bit smaller, and I just want to make an arc from the top out here in the middle somewhere. And then to be fair, since I made an arc from the top intersection point in the middle, I'm going to make the same arc from the bottom one somewhere out in the middle. And the place where those cross, if I connect that with my original vertex, that will be my angle bisector. And of course, we could take a protractor and try to measure it to sort of validate it. And you usually will find out that you probably didn't hit it dead on perfect, because sometimes you'll see, like right here, you might see that my arc, I slipped a little bit and there's almost 2 spots right there. They're very close together, but I might miss a little teeny bit in my measurement, and that's acceptable. We do that all the time. It's not really a big problem. It does take a little bit of practice to get better at it. So hopefully that was helpful in learning how to make a few constructions, and I will see you guys back in class. Bye-bye.